before we start, you all know that the importance of diagnostic testing, the medical decision making, and any good laboratory having a fully quality management in place still having errors occurring. What this error should be detected in time and the corrective action should be taken, and care should be taken that it reduces the impact of the. When I say any laboratory with full quality management system, will be having two independent but complementary systems in place, named as IQC and EQA. Now, what is EQA? EQA is External Quality Assessment Program. How does it operate? A blind sample sent to all the laboratories who are participating in the EQA program. Now, what is a blind sample? Blind, the sample is called blind because the concentration of the sample is not known to the laboratory who is running the or who has received the sample. The laboratory runs the sample similar to that of the patient sample. They submit the results back to the PT provider or EQA provider. EQA provider in the back end, they perform the statistical calculation, prepare an evaluation report and submit it back to the laboratory. For the laboratory to understand how the performance is and where are they standing in comparison to their peer. What is a peer? The other laboratories who is using same instrument, same method, and same reagent. So much of the value, what is more important in EQA is the EQA report. EQA report should be comprehensive enough, easy to interpret, and the information that is provided in the report should be useful to the laboratory. We'll try to understand how the quantitative report of any EQA program should be evaluated or understood. So, we from Red Dogs offer an external quality assessment program named as EQAS, that is Red Dogs International Quality Assessment Scheme. In the EQA report or the EQAS report, there is an individual parameter page available for each analyte. For each analyte, we provide 7 sub-reports that provide a variety of performance indicators and help the laboratory to understand the performance. The first part is a text section. This text section will study three parts. The first part is specifically important. The first real information, then 2 different boxes. The first part of text section gives you the information on the peer data. There are 3 peers, all method, the method that the lab is registered, and the instrument method and the reagent combination. That is called as instrument peer. Ideally, your results are compared with instrument peer, provided there are at least 5 participants in the peer. Okay, the results are reported in the units that is registered by the laboratory. If there are less than 5 participants in the initial instrument peer, then the results will be compared with the upper peer, that is method group. And again, if in the method also there are less than 5, it will be compared with the all method. Now, how these results are compared or how the statistics is calculated. So, the data that has been received has been compiled. The gross outliers are identified and marked as deactivated. And deactivated results are not used for the calculations of the peer data. And they are the deactivated results are flagged as exclusion. We'll understand how the calculations are done. The data is compiled, an average mean is taken. The mean is divided by 10 and multiplied by 10. So that is how a gross range is identified. Any result that is falling beyond this range is excluded. Following this, a sharpness criterion is applied and a statistical calculation is done. Now, for example, this is a set of 10 data. According to sharpness criteria, if there are at least 10 participants or 10 data is used, 10 number of data is used, then the SD factor should be 1.96. So, from the data, average is calculated, SD is calculated, and the number of results that we are using can be applied. So, the factor 1.96 is applied, multiplied with the SD, and that derived answer or derived figure is used as the range from the mean, plus and minus that specific value. In this case, 1.96 into 4.35, that was the SD, so answer is 8.54. So the mean plus and minus 8.54 and the range is derived. Again, any value that is falling beyond this range is excluded. This process is repeated for at least 3 times. After this, the 95th percentile of the new data or the new mean and SD is calculated, and the final range is identified, and the results that are falling beyond this range are excluded. These results are flagged in this exclusion column. Okay. Here the end shows number of participants. Those are included for the calculations of the peer data. The mean of the peer, CV, uncertainty of measurements, and standard deviation for performance assessment. You can also call it as the SD of the peer data. The next box gives you information on the performance indicators that are used to assess the laboratory performance. In EQAS, we use 3 performance indicators, namely SDI, that is standard deviation index, which people also know this as that score. So the limit of which is 3. The target score is unique with EQAS. Target score is a numerical index that is used to understand your performance at a glance. We all remember when we were studying this with college, we were getting marks for any subject. The marks were given out of 100 and the cutoff was 35. In this case, you can consider this as the marks for the specific analytic performance. The only difference is here the marks are given out of 120 and the cutoff is 50. Any number which is more than 50 is acceptable, below 50 is out of the acceptable range. And the third is percentage deviation, which is also known as the bias. Calculations of all these 3 performance indicators are interlinked. So if one is going beyond the acceptable limit, automatically the other will also provide it. If there is not on the one of them is not on the bottom. Okay. All 3 performance indicators gives the difference of the value that the lab has submitted from the peer mean or the target or the assigned value. As I said, the cutoff for SDI is 2. Target score cutoff is 50, and the percentage deviation cutoff is set by EQAS based on the historical acceptable data for the specific parameter. Trying to make it more stringent out of the acceptable data, they still cut the extreme 10% and make the more stringent acceptable limit. But in laboratory, if they are using some different guideline to assess their own bias, they can inform to us and we can set that limit for that particular laboratory. That will not affect calculations of any of the performance indicators. These are the formulas used for the calculations of performance indicators. SDI, your results that you have submitted minus the mean for comparison, that is a peer divided by SDPA, that is SD of the peer. Percentage deviation is your results minus mean peer mean divided by peer mean into 100. And the target score is calculated with this log-based formula. As I say, all these 3 performance indicators are interlinked. If the percentage deviation, there is one more term added, is TDPA. TDPA is nothing but the target, that is the acceptable limit of the percentage deviation set by EQAS. So if the percentage deviation achieved by the laboratory is equal to the TDPA, the target score will be 50. If the percentage deviation is more than TDPA, the target score will go below 50. That will be unacceptable range. And if the percentage deviation is less than TDPA, then the target score will increase. So lesser the percentage deviation, better will be the target score. Target score or TDPAs are set individually for each parameter. It takes into account the potential variability of the samples through the testing of homogeneity, reconstituted stability, real-time stability, and shipping or transport stability. There is an additional term appearing over here named as RM. RM stands for running mean. It is nothing but the average of last 10 samples, including the current. So this RM is calculated for all three performance indicators, SDI, target score, and percentage deviation. This will help you to understand the trend or shift over a time for the full range of the concentrations. If the third box, the information like biological variations are given, the acceptable limit of the percentage deviation is given, and if the results are out of acceptable range, then it will be flagged in this box, like SDI in the bottom 5% of the peer group, and target score and percentage deviations are outside the acceptable limit. The next part of the report is the histogram. Histogram is useful to to compare if there is any method or instrument related. Histogram helps to understand the comparison of method and instrument if there is any bias related to method and instrument. It shows the breakdown of the peer data expressed in terms of the bar graph. The white portion indicates all method. Green stands for your method, the method the lab is registered for the specific parameter. And the blue part indicates the instrument specific peer, the spread of the data. The triangle shows in which bar the laboratory results are lying. If there are any instrument or method specific bias, we can, the way it is reflected in this graph, we can see the blue portion has shifted on the right hand side, which means whichever parameter graph this is, the parameter run on that specific instrument is always recovering slightly on a higher side compared to all the other methods. The third section is a multi-method stat section. This again enables the assessment of the performance of each method. Here, all the methods that are registered for that particular parameter with us are listed. The number of participants that falling in that peer method here. The method mean for that particular sample is CV and the uncertainty of measurement. ISO/ISD guidelines says that each PT provider should calculate or should estimate the uncertainty for the assigned value to develop the confidence in the peer. So the uncertainty is calculated using the formula 1.25 into SD divided by root n. The n stands for number of results that are used for the calculations on data falling in the whole data. The uncertainty of measurement should be less than 30% of the SD. If the uncertainty of measurement is more than 30% of the SD, then uncertainty is combined with SD with the formula root of uncertainty of measurement square plus SDPA square. And a new SD is derived, named or flagged as SDPA adjusted. And the SDIs are then calculated using this newly flagged SDPA. It will be reflected as SDAA, this alphabetical array over there. And the SDIs will then be calculated using this new flagged SDPA. So there are 4 different graphs that are displayed or that are provided for each parameter. The first graph is the SDI performance graph, which is also known as edge graph. This graph appears similar to what we see in our IQC. Okay. In EQAS, whenever the results are falling in lighter zone in any graph, better is the performance. So there are three colors: the white, pink, and red. White stands for 0 to 1 SD. Pink is 1 to 2 SD, and red is 2 to 3 SD, which is unacceptable zone. SDI is calculated using the formula. Total 20 sample data points are displayed on the graph. The upper x-axis shows the mean that was used, the peer mean that was used to compare the particular number of the sample results. And the last is the current sample. The bottom x-axis shows the sample number, but when there is a correction in the sample, the C will appear instead of the sample number. And if the results are not submitted, then N will appear instead of the current sample or the sample numbers. The second graph is a target score chart. We've already discussed about target score. What is it? How it is calculated? This graph has a range. Again, on the bottom x-axis, it shows the sample number with the last being the latest. And the y-axis shows the scale of 0 to 120, where 120 is the best. 50 to 70 is acceptable. 70 to 100 is good, and 100 to 120 is excellent. 20 sample data points are plotted on this. The remaining two charts are of percentage deviation. One is by sample, the second is by concentration. So the percentage deviation by sample chart helps to identify if there is a trend or shift in the performance. Percentage deviation is calculated using the formula your difference minus mean for comparison divided by mean for comparison to 100. Again, 20 sample data points are plotted on the graph. Only two zones, white and red, that is acceptable and unacceptable. The point falling in red zone are out of the acceptable limit. And the y-axis shows the percentage deviation scale, which will differ from parameter to parameter. The colorless points are RM percentage deviation that is plotted on this graph. Trend line connects all the points. This helps you to understand if there is any trend or shift occurring in the performance of your data. The last graph is percentage deviation by concentration chart. This provides a rapid assessment of the concentration related points. In EQAS, we try to provide 7 different concentrations across the cycle, trying to cover the complete clinical picture. So, unlike other charts, here on the bottom x-axis, the sample numbers are not written, but the concentrations are written for the particular parameter. The y-axis shows the percentage deviation. And we can see here, again here 20 data points are plotted with the gray colored circular points are the previous sample data, whereas the current sample is denoted by black colored square point. If you see and look at this graph, you can easily understand that any results for this particular parameter, all the results that are reported at lower concentration is showing quite high variation. Similarly, in this graph, you can see that the lower concentration is performing quite well, whereas at higher concentration, the variation is low. This graph will actually help you to understand how the performance of calibration is there for the parameters in your instrument. The last page is the summary page, where we can see the red colored triangles for the parameters where all the performance indicators are outside the acceptable limit. They will be denoted by a red colored triangle. What does it mean? Okay, we'll look at a few of the couple of slides to understand how to interpret these charts. When we are getting this is the LJ chart. The first chart is the LJ chart, like SDI chart, we can see. When we are getting unspecific patterns, we are not able to understand what exactly this pattern says. We should always correlate this with the percentage deviation by concentration chart. to understand at which concentration or at which level of the concentration you are getting more variation. Here it clearly indicates that it shows a more variation at the lower concentration. Of course, when we are correlating this, we should always remember that the concentration level is very, very important. The LG graph also shows the concentration, that is the mean with which the results are compared at the top x-axis. And you can also compare the results, the variation from the top x-axis mean, that is. As I said, this graph will help you to understand the performance of the calibration for the parameter in your instrument. When we connect, if we connect this graph points with a trend line, from this graph, it is quite easy to understand that whichever parameter this graph is, the calibration has shifted in the calibration curve has shifted in such a way that at lower concentration it is giving higher values, whereas at higher concentration it is giving low values. So the curve at higher concentration is shifted on the upper side, whereas the same at the lower concentration shifted on the lower side. So this helps the lab to understand exactly at which level they need to take the corrective action. Once the cycle completes, we also provide an end of cycle report. End of cycle report provides the summary of the whole cycle, that particular parameter performance. Again, here a page allotted for each parameter that gives three information: summary of the submitted results, cycle-based statistics, and the cycle-based charts. Summary of all the submitted results, the cycle number, results, its unit, the number of participants which were there in that particular year, the mean, what mean it was here. In this case, it shows I stands for instrument mean. If it is method, M will appear, and if it is all method, then A will appear. The percentage CV, uncertainty of measurements, and all three performance indicators calculated for the specific parameter, which was reflected in your individual sample. So summary of the same is tabulated over here. Then the performance of that particular parameter is calculated, and or the average performance is calculated and is compared against the previous cycle performance of the same level. SDI and percentage deviation has negative values, which may get nullified while we take the average. So to overcome that, and that will not give a real picture. So to get the real picture of the performance, the absolute values are considered for SDI and percentage deviation. That includes, or that looks at only the magnitude and not the sign. And the absolute values are calculated, the average absolute values are calculated for SDI and the percentage deviation. All four graphs, the only difference is instead of 20 samples, only the total number of samples that are available in the cycle are plotted. In end of cycle report, there are two more informations, additional informations are given. First is performance before. Here it provides the graphical presentations of the performance based on the cycle average absolute SDI. Laboratory, country, and world, all three data are provided. S stands for laboratory, C for country, and the world, W stands for. The laboratory performance is compared against their own performance for the previous cycle with the absolute SDI. If the performance is improved compared to previous cycle, the point will appear in color. And if the performance is worsened compared to the previous cycle, the point will appear in red color. 0 to 3 SD line graph is plotted. The last page of the end of cycle report includes the certificate of performance. If the absolute SDI for the particular analyte is falling less, or is less, average absolute SDI is less than 2, then the performance is considered as acceptable. Else it is considered as out of acceptable limit. So the list of all the parameters will be given with a notification that the performance of following parameters are acceptable. And if the performance is going beyond acceptable limit, that SDI is more than 2 absolute SDI, then the performance will be considered as a poor performance. That notification will also appear over here. Following this, we'll understand how to troubleshoot. We'll look at few examples, how to troubleshoot when we get outliers in our EQA report. As we said, even if the quality system is there, the errors are bound to occur, but what is important is that the error should be detected, but the impact should be minimized. The laboratory quality control has moved from one-dimensional to two-dimensional, including LG chart, OSP, as rules. But actually, the laboratory control is multifaceted. What is important is not to look only at the quality control level, but also the quality management is very, very important. That includes IQC and EQA. Participation on EQA is not the solution. One needs to understand the report and look at the outliers, take the necessary corrective actions, and look at the implementation of the corrective action and then step back. So what should we do when we have poor performance in our report? We need to ask questions: what had happened? Why did it happen? How can it be prevented from happening again? And how do we know that the corrective action that we have taken has made the difference? It's a team approach, as Sir said very well. It involves technicians, quality management, laboratory director, everyone's. So first, when you receive your report, you have to look at the summary page and check if all the results are falling within acceptable limit. If yes, then you need to see if the performance over the cycle, how is it? If all, look at the LG graph, if all the results are falling on one side or if they are falling with 1 SD, plus or minus 1 SD. If so, you need to check for the trend, if positive or negative bias, poor precision or change in the performance. If there is an outlier, if you find that some of the parameter is going beyond acceptable limit, then first you need to check for the transcription error if there is any. If not, you have to check for the registration error. You have to review the summary page and check if majority of the results are flat. You need to check if the method and the instrument or the reagent that they have registered or the unit they have registered is appropriate. After doing all this, still if you find the performance is outside acceptable limit, you need to correlate it with the IQC and compare the IQC and EQA results. If you find that their IQC run was out of control or there was a shift of the trend, you need to do the RCA and take the corrective action. All the investigations that you do during your root cause analysis should be recorded, or the evidence should be recorded. You can have your own performance checklist where you could record all your investigation actions. The few possible reasons for getting systematic error in EQA are like reagent lot probability is expired or the open vial stability is expired. The control lot or the calibrated lots are expired. The calibration is done, but it is due. It was done long back and the requirement of calibration is there. The maintenance is done regularly or not. The parameter from volume, temperature, wavelength point of view, the application. We'll see a few troubleshooting examples. Starting with the introduction, we'll look at the summary page of the routine report. This is a summary page of the routine report. Here, few of the parameters are showing red color triangle. What does this mean? What is the meaning of this red color triangle? Which means that you should look at this parameter first. Whether the analyte has faced or failed for a specific performance indicator, or all the performance indicators are beyond acceptable limit, or whether it is indicating that long-term poor performance is there. When we study this summary page, we can see that for albumin, all three performance indicators are out. That is why the red color triangle is appearing. That means they all are beyond the acceptable limit. But when we see the overall performance of albumin, the RM target score is showing 90. That means overall the performance of albumin is good in the laboratory, but probably this particular sample was affected and the error could be the sample specific. There does not seem to be a systematic. Again, looking at the summary page, we have got this kind of picture. All the parameters are beyond acceptable, and for all we got this kind of red color triangle. What should be the first step? We need to check whether wrong sample was reconstituted or wrong sample was submitted, wrongly reconstituted, a dilution error. Was there any analyzer fault or is there any transcription error? What should be the first action? We'll check for the transcription error. But the chances are less because all the parameters are out. For all parameters, we cannot perform, we cannot make the transcription error. So we tried to rerun the sample. For that, the laboratory went to look for the sample in the fridge and they identified that the particular number sample was still lying in the fridge, unreconstituted, which indicates that they had submitted wrong sample. Now, how to understand this from this data? When we look at the percentage deviation, we can see most of the there are two kinds of error which can be easily identified from this kind of data. One is wrong sample, second is a dilution that are most likely giving this kind of picture. This is because of wrong sample, how we identify it. Because if we look at the percentage deviation differs for each parameter. If it is a dilution error, you may get this kind of picture. Percentage deviation is falling on one side and it is giving a similar percentage deviation for each parameter. Because the sample is over diluted and that is why all are getting all the percentage deviation coming with the reviews. Okay, so this is how we identified that probably this was a wrong sample and that is how they went and checked and they really identified the sample was. Again, looking at the summary page, we identified that one of the parameters is showing red colored triangle. Looking at this data, we are not able to understand what could be the possible error. So what we will do, we will look at the individual parameter page. When we looked at bioelastic individual parameter page, we identified that there was in the graph, there was a vertical line. Vertical line indicates change in the registration. And after making this change in the registration, the next immediate sample has gone beyond acceptable limit. We checked for acidity that lab has registered. It was correct. The method change shown on the report was a change of the reagent manufacturer, but the method remained same. It was just a current sample, so we also checked the EQAS. And of course, the percentage deviation graph here was showing only, the percentage deviation graph here was showing only 1 point going beyond acceptable limit. The graph was looking there. There's only 1 point was going beyond acceptable limit, and that the concentration was also quite different than the previous sample. We compared the data with the EQAS. We identified that all three EQAS were showing slight positive bias, but the concentration of EQAS sample was much more different than what it was there for EQAS. Then we studied the histogram and we identified that the lab was recommended by, they were using Beckman reagent. They were recommended by Beckman to change the to Sentinel reagent. And in the histogram, we can easily see two pairs, two data, two blue colored bars are there, blue colored portions are there. One is for the regular and the another is Sentinel reagent. So with this, we identified that probably the laboratory has not updated the method appropriately. And what they are the result they are submitting is falling in this another group. We discussed with EQAS and EQAS then changed or they created one more method for the Sentinel reagent. Avoid this kind of outliers. Again on the summary page, we can see these two triangles, two red colored triangles for ALT, AST both. And what the problem could be? Is the wrong sample reconstituted? Incorrect value is entered? Wrong sample is run? Is there any problem with the sample or assay details are incorrect or is there any transcription error? You can see ALT and AST values that they have submitted are changed. It's not only one parameter that is showing the red color triangle. It's both the parameters they are showing red color triangle. So the values are interchanged in transcription. You can submit the correction for this transcription error to get better performance in the end of cycle and to get acceptable certificate for the particular parameter. The fourth scenario is for alkaline phosphatase. We can see that individual parameter of page of alkaline phosphatase, the LJ graph shows the last two samples have gone beyond, much more beyond acceptable limit on a higher set. To understand the performance, we requested the laboratory to share their IQC data. When we studied the IQC data, it was identified that at the time the Zika sample was run, their IQC was also showing this kind of positive bias. We discussed this with the laboratory. Laboratory recalibrated the parameter, and after recalibration, the IQC came back with the C range, and also EQAS sample also came back with the acceptable. Many times we get this kind of question, my IQC is perfect, but I have constant negative bias in EQAS. What could be the reason? This could be the picture. This is the example of the sodium parameter. Whenever we are correlating our data on EQA results with IQC, what is important? Understand? We need to check how often the IQC was run and what was the concentration. Who is the supplier of IQC and what are the targets? Are they using manufactured means or they are set on the market? Many times it has been observed that laboratory assigned labeling, no issues. But before assigning the labeling, you must check the accuracy of the data. It's quite possible that when you assign the labeling, it hides the possible mask, it masks the possible bias that it could be indicated. See, ultimately, IQC or EQA, both are indicators that are used to identify if there is any bias in your data or if there is inaccuracy bias in your IQC or EQA results. Okay? Because in turn, it is going to affect your patient results, whether if it is showing positive, negative bias, again, your patient results are also going to give you similar difference in the actual values. So while assigning the labeling, it is very, very important that you please check your accuracy. If the accuracy is not affected, you can safely assign the labeling. Of course, what is also important, how wide the IQC ranges are there, and we need to compare this with the range with your EQA. It's very important to compare like with like. So the easiest way to compare IQC and EQA performance is to convert. EQA, you will be already having your percentage deviation. So convert your IQC performance into percentage deviation for the comparison purpose. Now, this is a set of the data that we had received. The laboratory provided 6-month data because they were getting a clear-cut negative bias. The target they had used was propagated cert, and they had not assigned the labeling. And the mean was also the achieved mean that they were getting was also quite close to the manufacturer target. The CV was also very less. It was just 0.5%, which was quite acceptable. And there was no result which ever went out of the 1SB acceptable range. When we converted this, or when we calculated the percentage deviation from the data, we could identify the level 1 average percentage deviation was 1.6%, and the same for level 2 was minus 1.4. When we try to compare this percentage deviation with EQA graph, we could identify that the EQA is also showing similar percentage deviation of approximately minus 1.5%, which is an average of level 1 and level 2. So their IQC was already indicating that there is a small bias, although it could be not clinically significant, but the same was reflected in. So the outcome was that the IQs itself showed the same deviation from the mean of comparison as that of the recursion. But in the larger the IQC acceptable range also gives false perception of the accuracy. While interpreting the report, it is very important to understand the report, evaluate for the poor performance, investigate the source of the problem, implement the corrective action, check the effectiveness of the corrective